In this video, I want to have a look at Pythagoras' theorem, what it is and how we can use it. So Pythagoras' theorem describes the relationship between the sides of a right-angled triangle. So Pythagoras' theorem is only true, I'm going to write that in capitals, it is only true for right-angled triangles. So if we have any other type of triangle, Pythagoras' theorem doesn't hold true. It has to be a right-angled triangle. So Pythagoras' theorem is written as c squared is equal to a squared plus b squared. So c, a, and b are all going to be numbers. C is going to be the length of the hypotenuse. So we know that that's the longest side of our right-angled triangle. And A and B are going to be the lengths of the shorter sides. So they're the lengths of the other two sides, and it doesn't matter which one's A and which one's B, as long as C is the hypotenuse. So if we have a look at this first example, we've got our triangle with 13, 12, and 5 as its side lengths. So that 13 is going to be our hypotenuse, and the 5 and the 12 are our two shorter sides. So we know that Pythagoras' theorem is c squared equals a squared plus b squared, and c has to be the hypotenuse. So for our triangle, this is going to become 13 squared is equal to 5 squared plus 12 squared. And we can show that that sentence is true because 13 squared is 13 times 13, which is 169. 5 squared is 25, and 12 squared would be 144. And if we add 25 and 144 together, you do end up with 169. So that 13 squared is the same, it's equivalent to 5 squared plus 12 squared. In our second example, the side lengths don't have numbers on them, so we can't go through and prove Pythagoras' theorem to ourselves. But because we're told that it's a right-angled triangle, we know that Pythagoras' theorem is going to be true. So we know Pythagoras' theorem is c squared equals a squared plus b squared. In this case, our c, our hypotenuse, is going to be this length here, which is p. So we're going to have p squared is equal to, and then our two shorter sides. So we could write m squared plus n squared, or if we'd written that p squared is equal to n squared plus m squared, that means exactly the same thing. So that's Pythagoras' theorem rewritten, just with the letters that were given in our problem. So it's an introduction to Pythagoras' theorem.